Good afternoon. If you've been following this series, you'll know I've been trying to make it easier for people to get a custom-made guitar if they need one for ergonomic reasons. I became aware of this problem because I severely busted up my left shoulder a few years ago, and I was able to make myself a custom guitar and allow myself to keep on playing, whereas I can't comfortably play any of the commercially available instruments that I own. But obviously, I recognised that it was unlikely that most people who experience some kind of injury are going to already own a CNC machine and be able to build a guitar. And so I've been trying to reduce the difficulty of getting that done lower and lower and lower over the last few years. And this weekend, I passed what I feel is a significant milestone. A few episodes back, I showed you that I had built the tooling in SolidWorks, which is a commercial 3D CAD application, that allowed me to say, here's a guitar body, here are the pickups I want, the bridge I want, the neck socket I want to attach the neck with, and now produce the guitar parts that I need to print to make that a reality. Now, that technology is, I thought, pretty cool to have, but it's not really helping anyone to say, you can do this as long as you've got a $2,000 a year professional CAD package. And so I've been working on ways to bring that level of difficulty down a bit. Now, the first thing one of the earlier things I did was try out using OpenSCAD, which is a free application to do this. And it worked, but again, the burden would have been you have to download this CAD package, open it up, edit this programming script to make it load the right parts for your guitar. You'd have to edit programming language, which is a thing that people I know are put off by, and then click go and then work out how to export the results. Now, I don't find any of those steps personally difficult, but I appreciate that I'm not really a normal person in the world of, what's acceptable level of complexity for using technology. So what I spent the weekend doing was working out how to make just a web page where you select the body, the pickups, the bridge that you want to use, and the neck you want to use, and it just creates those printable design files, and you go from there. So let me show you that. I'd like this episode to be one you can play along with at home. Like, this is a public website, so if you have a second screen and you go to Whiskey India Lima Lima Echo Romeo Zulu.github.io, you'll get this same page that I'm looking at now, and you can follow along and make your own custom guitar using options that I've never, but different to the ones I'm picking, and perhaps a combination that has never before been seen. So I'm going to click the link to try the prototype 3D printable guitar designer, and we get this page. Now, as I wrote here, and I'll read it out again, this technology didn't exist until a couple of days ago. I haven't been able to print out things that it produced and test them in real life. There hasn't been time then, and some of them I know that the software, the tooling parts were not complete. What I do think is complete is if you pick the option that starts with an S in every one of the selectors, I think that will result in a guitar that you could print and assemble and use. And if you wanted to do that, you would need to buy something like a Squier Classic Vibe Stratocaster to get most of the donor parts, and a Schaller 3D6 bridge and a new set of strings. And then you would be able to just transfer the parts and you'd have a custom guitar. It wouldn't look significantly different to your original Squier Classic Vibe Strat. But if you manipulated the printing recipe to reduce the weight of the guitar, you would be able to have one that's significantly lighter in weight. And I'd say go look at the previous episode for what that recipe looks like. Anyway, so we have to choose a body style. For trademark reasons, I can't say what any of these are intended to look like on the web page. But Bat-like was, let's say, inspired by the look of the Gibson and Epiphone SG range. So I'll just drink my tea. Later is inspired by the Epiphone, and there were some Gibson as well. The flat top Les Paul style starter. It's my take on the Strat type body, and Tasteful is my take on the Telecaster style body. So I'm going to pick, because I know it's one that works, starter, and the neck socket Strat, neck pickup Strat, middle Strat, bridge Strat, and the shallow 3D6. So this is one of the least adventurous combinations I could possibly pick, because all of these are basically my take on the Strat body. Then we're going to put a Strat neck on it, Strat pickups, and a shallow 3D6, which is a bridge that's designed to work as a hardtail bridge on a Stratocaster. So once I've made my selections, I click build my guitar. I'm going to try and measure in the audio stream the time between the click and the first frame where you see the results. There you go. A couple of seconds is what you should expect it to take, and then I get 2 parts STLs. So let's click that one and that one. So if I open those parts in a 3D viewer, which is a little bit complicated. I don't entirely know why the Windows 3D viewer thinks the back is the front. But if you spin it round, we can see that looks like a fairly sort of like a conventionally routed Strat body, but all of the cables are hidden internally, all the cabling's hidden internally, and and so we've got the neck pocket. Now, try and remember what that looks like, because it will be relevant in a couple of minutes. But let's look at the I'll also open the corresponding pickguard file, which is part 2. So there we go. We've got the pickguard, which has got a chamfer on it. As I said, this is experimental stuff. There is a problem here that we've got a sort of 0 thickness feature. Now, in my 3D printer slicer, it just doesn't print any plastic for those, but that's one of the problems that I'm seeing that I will need to figure out how to fix, and I will figure out how to fix. It just hasn't yet been done. But as you can see, or if you're familiar with what a Strat pickguard looks like, this is pretty much it. And just playing around with the 3D view options, trying to get you something that's easier to see. So yeah, we got the pickup slots, we got all the control stuff in the right place, and the screw holes correspond to the screw holes in the body. I'd ask you to trust me on that. But so the only problem is this 0 thickness feature here, which is an artifact of how the tooling was used. As I say, I'll fix that. Right, let's go back to the browser and let me make some changes. So choose something else. Let's choose something else. So let's do same body. This time we're going to say we've got a Telecaster neck to go on it. Let's say we find I'm a person who likes the ergonomics of the Strat body, but I don't particularly like I don't particularly love the pickups or whatever. So maybe I don't have a middle pickup. I love the Tele bridge pickup, and maybe I want a Jazzmaster neck pickup. Actually, I think this would be a pretty killer combination. And for the sake of fun, I'll say I'm going to put a different kind of bridge on it. This is more of a kind of bridge you'd use on a different style of guitar to either a Strat or a Telecaster. So again, I'll click build my guitar. I'm going to click part 1 and see, okay, I can see this, but for whatever reason, the downloads window doesn't show in the capture software, but it's a different file size to the original, to the first part. So let's switch back to, yeah, okay, so we've still got this kind of purple scene. Now, compared to what we saw before, you can see that the hole for the pickup is a different size because it needs to fit that for a Telecaster bridge pickup that we said. This fitment is now for a neck Jazzmaster pickup. Completely different, again, routing than we've needed for a Strat. The neck pocket, we said we wanted to put a Telecaster neck on it, and that means that this end piece here is straight now, whereas it was curved before. I probably should have pointed that out. And the corners are different. We don't have a middle pickup cavity at all. And let me show you what that has done to the pick guard. So obviously with a different pickup configuration, we need a different pick guard. So we've got, like, the control layout is the same, but we've got a big hole because we need to fit a Jazzmaster neck pickup in there. And we've got the 3-screw fitment and slightly bigger angled hole that we would need for Telecaster pickup. And we have a slightly different 0 thickness geometry glitch on the bridge area. And again, if you were to print these two parts and then assemble them using donor parts from a Squier Strat and a Squier Telecaster, and then a different and a P90 neck pickup from wherever you've got that, and this other kind of bridge, it would result in a playable guitar, I believe. And let's do something completely different. So let's do an SG type body. Strat necks are generally easier to find, so I'll do that. P90 in the neck, humbucker in the bridge. That's probably the right kind of humbucker in the bridge pickup position. That's probably the right kind of bridge to use for this class of guitar. And you can see that was is done differently because there are 3 parts to this guitar. So sometimes there'll be 2, sometimes there'll be 3. I'll just download all those STLs. Here is that SG style guitar that we've just made. So you can see the body is a silhouette quite like an SG. We have the normal SG type control layout with a design for control cover on the back. We've still got the string through holes that go with that Music Lily bridge we selected. We've got the connection for a Strat type neck with the curved end here. We've got the P90 pickup route for the neck pickup, the humbucker pickup route for the bridge pickup, and the mounting screws and everything for the pick guard and for the bridge. And if I open up the other 2 parts, we can see that the pick guard with the holes for the pickups, including the mounting points for the humbucker that we need, and we've got the control plate cover, which, as it happens, is identical irrespective of the options you pick on this body style. That's pretty much all of the functionality of this guitar designer. We've got, as I said, there's 4 options for body style, 2 options for neck style, technically 6 options for neck pickup, 2 for middle, and 6 again for bridge pickup at the moment. So 6 times. Off screen, I'm going to multiply all these numbers together and tell you how many combinations of guitar there are here, just in terms of shape. And I've got currently 3 kinds of bridge. My aim with this project is to help people who need some kind of adaptive guitar because of a problem that they have trying to play normal guitars. So I will be adding certainly my design that was designed to be ergonomic and lightweight for people who have some kind of back shoulder injury and just need something a bit lighter than the normal guitars. And the aim is to be a place where if anyone has designed an adapted guitar for someone, they could send me the body files. I could make it into the right kind of tool for this, and then other people who have that same kind of need for that same kind of adaptation can just use it directly. And similarly, I'd like it to be that if you know you're trying to design such a body, you could just design it to the standards that this uses. Use the same pickup and neck and bridge tooling to make your process a bit faster, so that your costs are lower when you have to make adapt a guitar for somebody else. And that's kind of the vision here, is just to make it easier initially, just for people who have the same kind of problem with guitars that I do. But as time goes on, for anyone who needs any kind of adaptation, I'd love to be able to build up a library of body styles that are helpful to anyone. I expect remove the 4 that are here now, because to the extent that having things that are not adaptive in the menu system is impeding the user from finding things that are adapted to their needs, that's why I'll probably remove them. So anyway, if you feel like giving it a go, give it a go. It's still a long way from easy to print one of these, because you'll need to make it fit on your print bed, which, unless your print bed is large enough to do it in one shot, is going to require you to cut the body up and work out how to glue it back together later, which is like that's non-trivial. You still will need to, in your slicer software, select the core region of the guitar, so the section that goes from underneath the bridge. You need to select the region that goes from underneath the bridge through to underneath the neck pocket, and set that to be 25% infill, 3 lines per infill, and aligned to go the lengthways on the guitar, so that it has enough strength to resist the pull of the strings. If you do that, you can print the rest of the body essentially completely hollow with just so I've been using lightning supports recently to get the weight of my printed bodies down as low as possible in that non-core area. And then, of course, you still need to successfully print it. You still need to do the assembly that you need to do to make it one whole part, rather than however many you had to cut it into for printing. And you still need to do the work of assembling a guitar from the parts, which, do not underestimate that. It's a very difficult task. Thank you for listening to this episode. If you were able to play along at home, thank you for that. Let me know if it worked for you or didn't work for you in terms of producing models. And as I said at the beginning, I know that some of the models are incomplete, so you don't need to tell me about that. But I'm reiterate it again: if you try this and it makes a model and you think, wow, I really want to print that, please check that, for example, there is space for the wires to get from the pickups to the control cavity in the model you selected. Some of them are much more complete than others, and I don't want I would hate for you to spend the day or so it's likely to take to print one of these bodies doing so, and then discover that actually Phil didn't, this is one of the ones I hadn't finished, and it won't work. So exercise caution, you have been warned. But as I say, I think it feels like quite a significant milestone, and I wanted to share it with you. Anyway, see you in the next episode. Cheerio.